June 26, 1943, France. The Thunderbolt is hit. It burns, it spins, it recovers. Later, on the ground, Robert S. Johnson tries to count the bullet holes. He gives up after 200. That is the kind of entry that sounds impossible. But it was not impossible. It was a P-47, and for the Luftwaffe, that was the problem. German forces had learned how to fight aircraft that were fast. They had learned how to fight aircraft that climbed well. They had learned how to fight aircraft that turned tightly. But the Republic P-47 Thunderbolt was something different. It was not delicate. It was not light. It was not built like a dueling blade. It was built like American industry had looked at the sky over Europe and said, "Bring the pilot home." The Germans captured one intact in 1943, a real P-47. Serial number 4222490. It reached the Luftwaffe test center at Rechlin on November 14th of that year. There, German evaluators could stop guessing. They could measure it, weigh it, fly it, inspect the armor, study the guns, trace the plumbing, look at the turbo system, look at the engine, and what stared back at them was not just an airplane, it was a national argument. The P-47 was heavy because it could afford to be heavy. It carried armor because America could build it. It carried fuel because America could supply it. It carried 8 50 caliber machine guns because America could feed them. It carried a massive air-cooled radial engine because the designers wanted an engine that did not quit just because one cooling line was hit. To the Luftwaffe, fighting a war under growing pressure, with materials tightening and options narrowing, the Thunderbolt was a shock. Its weight was not simply waste. Its weight was margin. Margin for the pilot, margin for damage, margin for the long flight home. And that is why one captured American fighter at Rechlin could tell Germany something it did not want to hear. The United States was not just building airplanes, it was building survivability at industrial scale. The first surprise was the engine. At the heart of the P-47 sat the Pratt & Whitney R2800 Double Wasp. 18 cylinders, 2 rows, air-cooled, about 2,800 cubic inches of displacement. More than 2,000 horsepower. It was one of the great power plants of the war. But the key word is not horsepower. The key word is air. The P-47 did not depend on liquid coolant to keep its engine alive. There was no vulnerable radiator system in the same way, no coolant line that, once pierced, could begin a countdown. No single leak that could leave the engine overheating and seizing within minutes. That mattered. A liquid-cooled engine could be smooth, it could be streamlined, it could be fast. The Merlin in the P-51 and Spitfire was famous. The Allison in the P-38 and P-40 had its own place in the war. But a liquid-cooled engine carried a basic vulnerability. Put a hole in the cooling system and the airplane might still fly for a little while. But the clock was running. The P-47's radial engine gave the pilot a different chance. Individual cylinders could be damaged, in some cases even knocked out, and the engine could keep running on the remaining cylinders, not forever, not magically, but long enough. And in air combat, long enough is everything. Long enough to dive away, long enough to reach friendly lines, long enough to make a field. Long enough to climb out of the zone where the enemy thought the story was already over. That was the first lesson the Luftwaffe had to face. The Thunderbolt did not need to be untouched to survive. It only needed to keep running. From the front, the P-47 looked almost blunt. A huge round nose, a radial engine up front, a big fuselage behind it. This was not a slender, delicate machine. Fully loaded, it could reach around 8 tons. For a fighter, that was enormous. Critics could look at that mass and see clumsiness. But combat gave it another name, reserve. The P-47's large fuselage meant it could absorb a lot of damage and still bring its pilot back. That is not romance. That is engineering. There was structure to lose before the airplane was lost. There was space to route systems. There was room for armor. There was room for fuel. There was room for a turbo supercharger installation that helped the airplane at high altitude. It was not weight for weight's sake. It was a design philosophy. Put protection around the man. Put a powerful engine in front of him. Put enough gun in the wings to end the fight quickly. Put enough structure around the whole machine to let it come home even after the enemy had scored hits, and then build thousands. The pilot sat with steel armor plate protecting him from the front and the rear of the cockpit. The forward view included armored, bullet-resistant glass. Under the cockpit, early P-47 arrangements included self-sealing main and auxiliary fuel tanks. The ex-P-47B's total fuel capacity was about 305 US gallons. Self-sealing tanks were not glamorous. No child drew them in a notebook. No enemy pilot feared them in a silhouette. But to the man inside the airplane, they were part of the difference between a machine that quit and a machine that fought to get home. The enemy could hit the Thunderbolt. That was not the question. The question was whether the hit was enough. Again and again, the answer was no. Now place yourself in the German test world at Rechlin in late 1943. An intact P-47 arrives because First Lieutenant William E. Roach of the 358th Fighter Squadron, 355th Fighter Group, had landed in German-controlled territory after weather, fuel, and confusion put him in the wrong place. He was taken prisoner. The airplane was delivered to Rechlin. For the Luftwaffe, this was a gift. A captured enemy fighter is a book you can open. They could examine performance, armament, handling, systems. They could study not a wreck, not rumor, not pilot reports from a brief combat pass, but a complete Thunderbolt. And the complete Thunderbolt told a hard truth. It was not just a fighter, it was a package. The radial engine, the armor, the self-sealing tanks, the 8 Browning AN/M2, 50 caliber machine guns, the heavy ammunition load, the turbo supercharger, the big structure, the durability, the ability to operate as an escort and later to punish ground targets. The meaning of that package went beyond a single aircraft. It pointed back across the Atlantic to factories, to aluminium, to engines, to machine tools, to fuel, to training, to logistics, to a country that could accept a heavy fighter because it had the industrial strength to make heavy work. German evaluators could see the trade-off. The P-47 was not the lightest, it was not the smallest. It was not designed around minimum mass, but America had built a fighter where mass became margin, and margin became survival. That is the part that could baffle an enemy pilot used to thinking in narrower terms. Why carry all that? Because the airplane could. Why carry 8 heavy guns? Because the industry could supply them. Why carry armor? Because the engine had power to haul it. Why build a huge turbo system into the rear fuselage? Because high-altitude performance mattered, and the aircraft could be engineered around it. Why make a fighter that could take punishment in ground attack? Because the war demanded it, and the United States could produce it in numbers. The Thunderbolt's turbo supercharger was driven by exhaust gases and mounted in the rear fuselage. That system helped give the P-47 strength at high altitude, where escort fighters had to operate with bombers. It was another sign of the airplane's character: big, complex, powerful, and very American. Not simple in the sense of being crude, simple in the sense of being brutally clear. Keep power at altitude. Keep the pilot protected. Keep the guns firing. Keep the engine alive. Keep the airplane coming home. The second surprise was the punch. The P-47 carried 8 Browning AN/M 2.50 caliber machine guns, 4 in each wing, around 3,400 rounds total. That gave roughly 31 seconds of continuous fire from all 8 guns. 31 seconds does not sound like much on the ground. In a fighter cockpit, it is an eternity. Air combat happens in flashes, a nose crossing the target, a burst, a correction, another burst, a few seconds at a time. The Thunderbolt did not need mystery weapons. It did not need exotic solutions. It carried 8 hard-hitting, reliable American heavy machine guns with a deep ammunition supply. That mattered in escort work. It mattered in fighter sweeps, and it mattered even more as the Thunderbolt became a fighter bomber. Because the P-47 was not only built to survive in the air, it was built to work down low, where the air was crowded with danger. Ground attack is unforgiving. The aircraft flies closer to enemy fire. There is less time to recover from damage, less altitude to trade for survival, more small arms, more flak, more chances for something to hit a line, a tank, a cylinder, a cable, a wing. This is where the air-cooled radial engine became more than an engineering preference. It became a life insurance policy. A liquid-cooled fighter could be deadly, but if a cooling line was pierced during a low-level attack, the pilot might have only minutes before the engine overheated. The Thunderbolt's radial engine did not have that same coolant vulnerability, and the P-47's structure could take punishment. This is why the aircraft earned its reputation in the brutal business of fighter-bomber operations. It could carry up to 2,500 pounds of bombs or 5-inch HVR rockets. It could strafe. It could bomb. It could attack transportation. It could support advancing forces. It could dive into the work that wore aircraft out. And then, often, it could come back. That last part is the whole story, coming back. The war in Europe was not won by single dramatic moments alone. It was won by repeated sorties, day after day, mission after mission. Aircraft launched, returned, repaired, refueled, rearmed, and launched again. The Thunderbolt excelled in that rhythm. Across its combat service, the P-47 flew more than 746,000 sorties. It lost 3,499 aircraft from all causes. That is a loss rate of about 0.47%. For a heavy fighter bomber doing dangerous work, that number is astonishing. It is not a claim that the aircraft was invincible. No aircraft was. It is proof that the design gave pilots a better chance when hit, a better chance when low, a better chance when far from home, a better chance when the mission did not go as planned. And in war, better chances add up. They add up to pilots who return. They add up to squadrons that keep operating. They add up to pressure on the enemy that does not let up. In the European theatre, P-47s dropped 113,963 tons of bombs. They were credited with destroying more than 7,000 enemy aircraft, with that total including many destroyed on the ground, along with thousands of tanks, vehicles, and locomotives. Those numbers are not just statistics. They are logistics turned into combat power. They are factories turned into airfields. They are maintenance crews turning wrenches before dawn. They are ammunition belts loaded into wings. They are bombs fitted under aircraft. They are pilots climbing into cockpits protected by steel plate and armored glass. And they are German forces forced to face a machine that could arrive, hit hard, take damage, and return to do it again. That was the nightmare for the enemy. Not that one P-47 survived once, but that thousands could survive often enough. The United States built 15,636 P-47 Thunderbolts between 1941 and 1945. That made it the most produced American fighter of the war. Think about what that meant to Germany. A single tough airplane is a curiosity. 15,000 tough airplanes are a strategy. Rechlin could inspect one captured Thunderbolt. German test pilots could fly it. Engineers could trace its systems. They could understand the choices. They could admire parts of the design and criticize others. But they could not make the American industrial base appear in Germany by studying one captured fighter. That was the deeper humiliation. The P-47 was not just better armor, not just a radial engine, not just 8 guns. It was the visible edge of a system, and the system was bigger than the airplane. The third surprise was the proof in combat. June 26, 1943. Robert S. Johnson was flying with the 61st Fighter Squadron, 56th Fighter Group, 8th Air Force. The mission was bomber escort on the return from an attack in France. Then WWII-190S attacked. Johnson's Thunderbolt was hit. It caught fire. It went into a spin. That should have been the end, but he recovered. The fire went out. The airplane was damaged, but it was still flying. This is the moment where design leaves the factory drawing and enters history, because no engineer can promise a pilot that the enemy will hit the convenient place. No designer can choose the angle of attack, the burst length, the weather, the fuel state, the pilot's fatigue, or the second enemy fighter that appears after the first disaster. All engineering can do is build margin. Johnson's P-47 had margin. As he moved away, a WWII-190 came in again. The German pilot apparently had already used his 20mm ammunition and was firing only the two 7.92mm machine guns. Johnson's Thunderbolt absorbed hundreds of hits from those guns. Hundreds. Not one, not 10. Hundreds. The German kept firing until he ran out of ammunition. Then something remarkable happened. The Luftwaffe pilot pulled alongside Johnson's damaged Thunderbolt. He rocked his wings in salute. Then he turned away. We do not need to know his name to understand the moment, and historians caution that the identity of that German pilot is not confirmed. What matters is what he saw. He saw an American fighter that had been hit, burned, spun, recovered, and kept flying. He saw his own fire fail to finish it. He saw ammunition disappear into a machine that refused to fall. That was not magic. That was the R2800 radial. That was armor. That was structure. That was self-sealing protection. That was American design refusing to make survival an afterthought. When Johnson landed, he tried to count the bullet holes. He gave up after passing 200. Robert S. Johnson would go on to become one of the leading P-47 aces of the war, with 27 confirmed victories. But on that June day, the victory was more basic. A pilot came home. An enemy pilot had to watch him come home, and the Thunderbolt's reputation hardened into legend. Now, legends can be dangerous. They can stretch. They can become too neat. They can turn machines into miracles. The P-47 was not a miracle. It was better than that. It was engineering. A miracle cannot be mass-produced. The Thunderbolt could be. That is why the story of durability matters. It is not about claiming the P-47 could survive anything. It could not. Pilots were lost. Aircraft were lost. The war was dangerous every time the wheels left the runway. But compared with many fighters of its era, the P-47 gave its pilot exceptional odds when damaged. Its air-cooled radial engine removed one major vulnerability. Its big structure could absorb punishment. Its armor protected the cockpit. Its self-sealing tanks improved survivability. Its heavy armament let it strike with authority. Its turbo system made it formidable at altitude. Its bomb and rocket capacity let it shift into ground attack with devastating effect. And its production numbers meant the enemy faced it again and again. The Luftwaffe could respect speed. It could calculate climb. It could measure turn radius. But the P-47 forced German forces to confront something more frustrating. An aircraft could be hit and still be a problem. Hit it in the engine, and the radial might keep turning. Hit it in the structure, and the mass might absorb it. Hit it in the fuel system, and self-sealing tanks might limit the damage. Hit it in combat, and if the pilot could nurse it home, American ground crews could repair it and send it back. The enemy was not just fighting airplanes, it was fighting recoverability. That is a word that rarely gets glory, but it wins wars. Recoverability means a damaged aircraft does not automatically become a total loss. It means a pilot with experience returns to fly again. It means a squadron does not have to start over. It means the industrial effort invested in one aircraft continues to pay back. It means pressure on the enemy remains constant. For German forces in Europe, that constant pressure became unbearable. Thunderbolts escorting bombers, Thunderbolts sweeping ahead, Thunderbolts diving on transportation targets, Thunderbolts carrying bombs, Thunderbolts firing rockets, Thunderbolts returning with damage that would have doomed more fragile machines. And every time one returned, it carried a message. You did not do enough. That message had weight. The P-47's weight. The same weight that critics could mistake for inefficiency. The same weight Rechlin evaluators had to interpret not as dead burden, but as deliberate margin. Imagine the captured Thunderbolt sitting at Rechlin. German technicians remove panels. They see the arrangement of systems. They study the wings with 4.50 caliber guns each. They examine the radial engine up front. They look at the turbo supercharger system routed to the rear fuselage. They see armor around the cockpit. They assess handling and performance, and they understand the contradiction. This is a fighter, but it is built like it expects to be hit. That was the American answer to the air war, not simply, do not get hit. Every fighter pilot wanted that. The Thunderbolt added, and if you are hit, keep flying. This is why the aircraft became beloved by many who flew it in the harshest missions. It gave confidence, not false confidence, not invincibility, but a sense that the airplane was on the pilot's side when things went wrong. That confidence changes behavior. A pilot who trusts his aircraft can press the mission. He can dive into ground attack, knowing the machine has a fighting chance of absorbing damage. He can nurse a wounded engine. He can believe the airplane might forgive one bad moment, one burst from the enemy, one line of fire across the nose, and belief matters as long as the engineering backs it up. With the P-47, it did. The Pratt & Whitney R2800 was not just a large engine, it was a rugged foundation. The air-cooled radial layout gave it tolerance to damage compared with liquid-cooled engines. The lack of coolant to leak was a decisive advantage, and because individual cylinders could be damaged while the rest continued to operate, the pilot had options after hits that might have ended another aircraft's flight. That is not glamorous. It is better. It is practical courage, cast in aluminium and steel. The armor plate around the cockpit was the same kind of thinking. It accepted that the enemy would shoot back. It accepted that no pilot could avoid every burst, so the design gave him protection. The self-sealing tanks accepted the same truth. The big airframe accepted it. The 8 guns accepted another truth. If the P-47 got a firing chance, it needed to make that chance count, and with 8.50 caliber Brownings and roughly 3,400 rounds, it could. Then came the fighter-bomber role. Many aircraft that shine in one job suffer when asked to do another. The Thunderbolt's strength made it adaptable. It could carry heavy external loads, up to 2,500 pounds of bombs, or 5-inch HVR rockets, that turned an escort fighter into a powerful tool for attacking enemy ground targets. Again, durability mattered. A ground attack aircraft lives in the enemy's reach. It does not merely duel other aircraft at altitude. It enters a world where many weapons can hit it. A tough radial-powered fighter with armor and mass had obvious value there. German forces on the ground had to face this. They were not just dealing with a fast pass overhead. They were dealing with an aircraft built to take the risks of coming low. In the European theatre, the result was immense. More than 113,000 tons of bombs dropped by P-47s. More than 7,000 enemy aircraft credited destroyed in total, including many on the ground. Thousands of vehicles, tanks and locomotives destroyed. Those figures show why durability was not a side feature. Durability made tempo possible. Tempo made pressure possible. Pressure made superiority visible. The captured P-47 at Rechlin was a warning sign, but the skies and roads of Europe delivered the warning every day. The Luftwaffe could test one aircraft. German forces had to endure the campaign, and the campaign showed the same lesson over and over. A Thunderbolt that survived today could fight tomorrow. This is the hidden arithmetic behind the 0.47% loss rate across more than 746,000 sorties. Every fraction point mattered. If aircraft survive at a higher rate, units stay stronger. Experienced pilots remain in action. Maintenance crews repair rather than replace. Supply chains support operations instead of constantly filling gaps. Commanders can plan with confidence. That is how a durable fighter becomes more than a tough machine. It becomes a multiplier. The P-47 multiplied American effort because it preserved American pilots and aircraft better than many enemies expected. And that preservation had a moral weight for the men who flew it. A machine that brings you home becomes more than equipment. It becomes a promise, not a guarantee. A promise. The difference matters. A guarantee says nothing can happen. A promise says, if there is a way back, I will help you find it. For Robert S. Johnson, on June 26, 1943, that promise held. His Thunderbolt was attacked. It was damaged. It burned. It spun. It recovered. It absorbed hundreds more hits. It stayed in the air until the enemy ran out of ammunition. Then it landed, and the pilot stopped counting holes after 200. That is the story the Luftwaffe had to face, not because German pilots lacked skill, not because German engineers could not understand machinery, but because the P-47 represented a combination they could not easily match as the war turned against them: power, protection, firepower, altitude performance, bomb load, repairability, production, and above all, margin. Margin is what a wealthy industrial democracy could build into a fighter when the goal was not elegance alone, but endurance. The Thunderbolt did not ask to be the prettiest fighter in the sky. It asked to be the one still flying after the enemy thought the fight was over. And that is why the Jug became a source of American pride. It carried the marks of the country that built it. Big engine, big guns, big structure, big production, big faith in the pilot's life. To the Luftwaffe test world at Rechlin, the captured P-47 was evidence. To German forces in combat, it was experience. To American pilots, it was a fighting chance wrapped in metal. The Thunderbolt could be hit, it could be scarred, it could be underestimated, but time and again, it did the one thing that mattered most. It came home. And when it came home, the enemy had to understand. American superiority was not just speed in the sky, it was the strength to survive the sky.